Hello students, today we are going to discuss new algebraic method, that is cross multiplication, that is used for finding the solution of linear equations. How this method is used? Now let us see. It is exercise 3.5 and whose first question is, which of the following pair of linear equations has unique solution, no solution, or infinitely many solutions? In case there is a unique solution, find it by using cross multiplication method. And part number first. This is x minus 3y minus 3 is equal to 0, and second is 3x minus 9y minus 2 is equal to 0. These are two equations. First of all, we have to check its solution, whether that is unique or that is no solution or that is infinitely many solutions, by equating it to the standard equation. Comparing equations 1 and 2 with ax plus by plus c is equal to 0, we will get the coefficient of x is a, and here the coefficient of x are 1 and 3. So a1 will be 1, a2 is 3. b1 is equal to coefficient of y, that is minus 3, and b2 is equal to minus 9, and c1 is constant term, that is minus 3, and c2 is minus 2. And now we shall find the ratios of these coefficients. Therefore a1 over a2, that will be 1 by 3, b1 over b2 is equal to minus 3 over minus 9, and that will be by solving 1 by 3. And if these two ratios are equal, then we will check the third one, and c1 over c2 is equal to minus 3 by minus 2, and we see this is 3 by 2, and so a1 over a2 is 1 by 3 is equal to b1 over b2, because it is also 1 by 3, and but these are not equal to c1 over c2, because c1 over c2 is 3 by 2, and so this is a case of no solution. Therefore we can see, therefore the system has no solution. And they are saying, if the system has no solution or many solutions, then we have no need to find the solution, because we will find the solution of this system of equations when it is a unique solution, and in this case we will not find the solution, because solution doesn't exist, no solution, so we will not find this solution. And this is our first part. Next part of our question is 2x plus y is equal to 5 and 3x plus 2y is equal to 8. In these equations, you can see the constant terms are on the right hand side of the equation, or in other words, you can see there is no zero on the right hand side of these equations. So when we are using cross multiplication method, then it is important to make the right hand side of the equations 0. How? You can write them as 2x plus y minus 5. You will shift this constant term to the left hand side of the equation, and the right hand side will be 0. So this will be also like 3x plus 2y, and this will be minus 8 here. it is important step when we are using cross multiplication method. Now first of all we will check whether this is a system of unique solution or not, for which we will compare these equations, that is 1 and 2, comparing 1 and 2 with ax plus by plus c is equal to 0. I am again taking 0 here, and so in this way I will get a1 is equal to 2, a2 is equal to 3, b1 is equal to 1 because the coefficient of y is 1, and b2 is equal to 2, c1 is equal to -5, and c2 is equal to -8. And for ratios, a1 over a2, that will be 2 by 3, b1 over b2, that is 1 by 2, and so 2 by 3 is not equal to 1 by 2, and therefore a1 over a2 is not equal to b1 over b2. Therefore the system has unique solution, and we will solve the system by cross multiplication method. How? Now come to this side. Write x, y and 1. First of all, you will leave these two coefficients, and these coefficients will be cross multiplied with each other. First of all, we will multiply 1 with 8 minus 2 into -5. That will be 1 multiplied by -8 and minus 2 multiplied with -5. Now for the denominator of y, we will leave these two coefficients and we will not consider these coefficients, and we will multiply 3 into -5 minus 2 into -8, and last term is these two coefficients will be omitted, and we will again multiply this 2 with 2 minus 3 into 1. This is a proper pattern. When you are leaving these two coefficients, then you will multiply these four coefficients like this minus this. This will be a plus and this will be a minus. When you are leaving these two coefficients, then you will take this minus this. This will be the opposite of the previous system. And the third one is same as of the first system, that will be by leaving these two coefficients you will get this one minus this one, and you see these two patterns are same, and this is of opposite of these two patterns. And now we will solve these coefficients multiplication, and it will be -8 minus minus plus 10 minus 15 minus minus plus 16, 2 2s are 4 and minus 3. It will be x over 2, y over 1 and 1 over 1. Now we will take two relations, this relation with this, x by 2 is equal to 1 by 1, and here we will take the relation of y with constant, y over 1 is equal to 1 over 1. First and third, second and third. first and third here and second and third is here, and by solving you will get x is equal to 2 and y is equal to 1, and this is our required answer. X is equal to 2, y is equal to 1, and this method is called cross multiplication method for solving the linear equations. Next question is 3x minus 5y is equal to 20 and 6x minus 10y is equal to 40. Again, we will make this side of the equations 0 by shifting this constant term to the left side. It will be 3x minus 5y minus 20 is equal to 0, and it will be 6x minus 10y minus 40 is equal to 0. This is first equation and this is second. Now we will equating or comparing 1 and 2 with ax plus by plus c is equal to 0. We will get a1 is equal to 3, a2 is equal to 6, b1 is equal to minus 5, b2 is equal to minus 10, c1 is equal to minus 20, and c2 is equal to minus 40. And the ratios a1 over a2 is equal to 3 by 6, and it will be 1 by 2 by cancelling. b1 over b2, it will be minus 5 over 10, and by cancelling it will be 1 by 2 again. And if these two ratios are equal, then we will skip to the third one. c1 over c2 is equal to minus 20 over minus 40, and it will be again 1 by 2. And this is a condition when a1 over a2, b1 over b2 is equal to c1 over c2, because these three ratios are equal, and so the system has infinitely many solutions. So if this case exists, then there is no need to find the solution of the equations. So this is our answer. Last and fourth part of the equation of the question 1, and this is first equation, this is second. There is no need to reform the equations because the constants are already on the left hand side of the equation. So we will start by this step, comparing the equations 1 and 2 with ax plus by plus c is equal to 0, and we will get a1 is equal to 1, a2 is equal to 3, b1 is equal to minus 3, and b2 is equal to minus 3, c1 is equal to minus 7, and c2 is equal to minus 15, and so a1 over a2 is 1 by 3, b1 over b2 minus 3 over minus 3, and by solving it will be 1. And we see these ratios are not equal, therefore we will not check the third one. a1 over a2 is not equal to b1 over b2, and therefore the system has unique solution. Now for solving, we will take x over y over and 1. And again we will omit these two coefficients and we will multiply this minus this one minus this one, that is minus 3 into minus 15 minus minus 3 into minus 7, and y over we will meet this one and we will take opposite of the previous system, that is this minus this, 3 into minus 7, and after that 1 into minus 15, and last one is again by omitting these two coefficients, this minus this, that is minus 3 into minus minus plus 9, and it will be x over plus 45 minus minus plus plus minus minus 71, y over minus 21 minus minus plus 15 and 1 over 9 minus 3 will be 6, and here x will be 45 minus 21, 1 will be 24, and this will be 6 of negative sign and 1 over 6. Again we will take first and third relation. 24 is equal to 1 by 6, and so x is equal to 24 by 6 will be 4, and if we take second and third, that will be y over minus 6 is equal to 1 over 6 and y is equal to minus 6 over 6, and it will be minus 1, and therefore our answer is x is equal to 4 and y is equal to minus 1.